So let's start with showing true. Show true for n equal 2. So 5 squared plus 9 is smaller than 6 squared. So I have 25 plus 9. That's smaller than 36. Check. Okay. So I'm going to assume true for n equal k. So I get 5 to the k plus 9 is smaller than or equal to 6 to the k. Again, make sure you know you're going to use that. So I'm going to show true for n equal k plus 1. So 5 to the k plus 1 plus 9 is smaller than or equal to 6 to the k plus 1. Okay. So let's take this left-hand side, and I'm going to break this up into what am I going to do? Let's see. This is going to be 5 times 5 to the k plus 9. Now, how am I possibly going to get that to be smaller than a 6? So this 5 is not going to break up into getting me a 6. Ooh. Oh dear, I'm going to have to think of something more clever. Okay, so let's go over here to the clever thing. So this I know is true, right? This is true. I'm going to be using that inductive step. How about if I multiply both sides of this by 5? Okay, so what would that give me? That would give me 5 to the k plus 1. And if I distribute this 5 to this 9, I get plus 45, and that's smaller than 5 times 6 to the k. And the only reason I'm thinking of doing something different is that this 5 isn't breaking up like the other examples, is it? Okay, so what do I know about this? So don't I know that this, which is 5 to, let me just write it again, 5 to the k plus 1 plus 9, isn't 5 to the k plus 1 plus 9 going to be smaller than 5 to the k plus 1 plus 45? Right? This has plus 9, this has plus 45. Yes, I do know that. Okay. So then what do I know? I know that this is smaller than or equal to 5 times 6 to the k. So in a clever way, I've used my inductive step. And then where am I trying to go again? Oh yeah, I'm trying to get to this. So isn't it true that 5 times 6 to the k is smaller than 6 times 6 to the k? And that's equal to 6 to the k plus 1. Whew, that's clever. And so again, how do I know I need to use clever when that number in front isn't going to multiply or break up into things? So that's when I want to think about multiplying. All right, so let's go to this one. And I gave you an example to do for Zoom. So this is a good way for me to show you this. So this is telling you to prove this, and it's telling you you're going to need to use this in the midst of a proof. Okay, so let's go. So I want to show true for n equal 5. So I get 5 squared is less than 2 to the 5th. 25 is less than 32. Check. Okay, so I want to assume true. N equal k. So I get k squared is less than 2 to the k. Okay, so now show true for n equal k plus 1. Here we go. K plus 1 squared is less than 2 to the k plus 1. Okay, let's multiply this side out because, again, I want to be able to use this inductive step in some way. So there's a k squared inside there, right? So k squared plus 2k plus 1 on the left-hand side. All right, so let's use my inductive step. So this can be taken out, and I can replace it with less than 2 to the k, right? Take out k squared and replace it with less than 2 to the k. So less than 2 to the k, and then I carry the other parts along. Good? All right, so now what do I need to do? What am I trying to get to again? I'm trying to get to 2 to the k plus 1. Oh yeah, look at what it said to use. 2k plus 1 is less than 2 to the k. There it is. So I'm going to take this out and replace it with less than 2 to the k. So less than 2 to the k. And this 2 to the k carries along. And oh my goodness, I have 2 of them. So this is the same as saying 2 times 2 to the k, which is 2 to the k plus 1. Check. Got it. And I'm going to let you do this one on Zoom.